Hey everyone, welcome to a new series from Easy PC Builder on how to build your computer. Today we go through each of the components individually. We go through the case, the motherboard, the CPU, the RAM, the storage devices, the CPU cooler, the graphics card and the power supply. Let's start with the case first. So what's the role of a case? Its main role is to house and secure your computer components to provide the best environment for them that's free of static, dust and liquid, and provides good airflow for the components as well. So what's inside the box when you buy a computer case? Generally you'll get the case itself, and inside the case will be a user manual and a series of screws in there to mount down your power supply, your motherboard and drives into the case. You also get a few cable ties as well for cable management. And we've got a case here as well from a different manufacturer with similar things enclosed. We've got the case itself, the user manual, and the screws for the power supplies, the motherboard and the drives, and some cable ties in there as well for cable management. So computer cases come in different sizes as well, mainly to suit the purpose if it needs to be compact or if perhaps it needs to be transported. Here we've got a micro ATX case and a mid ATX case, but you can buy the size depending on your purpose. Your case needs to be compatible with your motherboard chosen. The most common size motherboard size being standard ATX, micro ATX, mini ITX, and for some higher end systems which require more components, extended or full ATX. The case size that you buy reflects the limiting size or the largest motherboard that you can install into the case. For example, if you purchase a micro ATX case, you can't fit a standard ATX board into it, but you can fit a micro ATX board into a standard ATX case, which is quite common. Case might be best. Consider thermal dynamics when buying a smaller case also, as a smaller case usually means components can obstruct the airflow through the case. And verify that your graphics card length and CPU cooler height, if you're using an aftermarket cooler, is compatible with the case that you've chosen. So outside of the size of your case, you've also got a few other options. You can choose cases with windowed sides. You can get them in black, white and aluminium. You can get cases that support water cooling as well. And generally the price of the case will reflect the quality of the case as well. Generally the more expensive cases will have thicker metal that they use in the construction, which is generally better for keeping the case quiet. And you also get a few other features as well, such as removable drive bays and better cable management. So if you'd like to learn more, jump over to our website at easypcbuilder.com, where you can download our monthly updated build guides for gaming PCs of various levels, office PCs and media PCs, and you can also download our Easy PC Builder Master course. So what's the role of your motherboard in the computer? It provides the primary connection and interface control for all the components in your computer. The motherboard and the chipset installed on it provide the power to the circuits, and in conjunction with the CPU define the when, where and how of the data to be transferred to and from each of the components connected to the motherboard. So what's inside the box when you purchase a motherboard? You've got the motherboard itself, you've got the motherboard backing plate for the case, you've got the driver CD for the motherboard, you've got the user manual for the motherboard, and in this case here we have two SATA data connectors and an additional two SATA data connectors as well. So these are used for your solid state drives, your hard drives and your DVD-ROM connections. So let's overview the motherboard. Here we have our CPU array, we have our 4 CPU cooler mounting points, we have our CPU fan connection, we have our 4 RAM module connection points, we have our PCI Express slots, we have our M2 connectors, We have a 24-pin motherboard primary power connection. We have a 8-pin secondary CPU power connection. We have our motherboard mounting points. We have our USB 2 headers, our USB 3 headers. We have our case interface header. We have on this side of the motherboard our serial ATA ports, and on the back of the motherboard here we have our PS2, USB, USB Type-C, HDMI, other USB slots. We have our Ethernet connection and audio outputs from the motherboard. So some main considerations when buying a motherboard would be: what type of CPU do you want to use? How configurable do you want the motherboard to be? How many graphics cards are you going to install? How many hard drives, solid state drives and SATA ports do you need? How many RAM slots are required? And how many expansion slots for other cards such as sound cards, Wi-Fi cards? All of these options will define the budget, the size and the chipset required on the board. You've got a choice of a number of motherboard sizes when you purchase a computer. Generally, the larger amount of expandability that you need, the larger the motherboard. Now, the motherboard size and the mounting holes change based on the size of the board that you choose. Common motherboard sizes are ATX Extended, ATX Standard, Micro ATX and Mini ITX. Generally, the motherboard requirements define the size of the case required, not the other way round. So in front of me, I've got two different size motherboards. This one here is a standard ATX motherboard, and this one here is a micro ATX motherboard. They're the same width, but the length of the board of the micro ATX board is slightly shorter, which means it has slightly less expansion than the standard board. All motherboard sizes are standardized, which ensures that the boards will be compatible to cases made by many different manufacturers and ensures wider compatibility and availability of cases. Now, we touched lightly on the motherboard chipset before, which its main role in conjunction with the CPU is to define the when, where and how of the data to be transferred to and from each of the components connected to the board. The motherboard chipset is paired to the CPU type used. The supporting motherboard chipsets are generally released and phased out at the same time as the CPU to ensure maximum compatibility, but it is still something you'll need to check. Due to the large amount of data being transferred between the RAM and the graphics cards to the CPU now controls the data flow from the RAM and the graphics cards directly, interfacing to the motherboard chipset for the lower bandwidth tasks such as USB, SATA, networking and other slower PCI Express slots. So one chipset type can support a manufacturer's CPU of many different speeds and cores, but the type of chipset that you choose is dependent on what you want to use the computer for. Manufacturers mainly offer 3 tiers of chipsets, all of which offer the same base performance, but some offer greater expandability and configurability, such as being able to run multiple graphics cards or to overclock. The base chipsets at present are Intel's B series and AMD's A series, which can be used for office and mid-range gaming PCs. The chipsets which generally support multiple graphics cards are the H and B series, generally used by high-range gaming PCs, and the chipsets which support all of the above and overclocking are the Z and X series, used by high-end gaming PCs. So a motherboard and computers in general provide for standardized interfaces. For example, your serial ATA, your RAM, your PCI Express, your USB and your M2 connections are all engineered with various committees and manufacturers, and a final standard or way of implementing this interface is decided and then applied. This standard interface is what provides consistency and allows many manufacturers to produce compatible equipment for many types of interfaces across many different types of boards. For example, you can use an AMD graphics card in an Intel chipset motherboard, even though they're competing manufacturers, or say using a Kingston DDR4 RAM in a Gigabyte motherboard. Providing the standard interface connector is present, these will be compatible. This allows manufacturers of all different types to produce products compatible across manufacturers and ranges, such as using an ASUS manufactured video card on a Gigabyte manufactured motherboard. For example, these two motherboards here, aside from their size differences, the main difference is that they each support a different CPU type with their accompanying motherboard chipset. For the remainder of the interfaces, many of the other parts I have here would fit in either, providing the interfaces were compatible, such as the PCI Express, the DDR4 RAM, and the SATA interfaces on the boards. And a few quick motherboard tips. When you're installing your motherboard, remember you've got your primary motherboard power, but also don't forget to install your CPU power supply. And as well, when you're choosing motherboard types or specifications, if you're after ones with specific Wi-Fi or sound in them, you might be able to make a saving by buying separate PCI Express cards, which may be of a higher quality than those that could be incorporated in a more expensive motherboard itself. So if you're enjoying the series so far and you do have an ad blocker turned on, it'd be really appreciated if you could turn it off. The ads run on the videos are our primary form of revenue. So now onto the CPU. So what does the CPU do in the computer? It essentially provides the computing power for program execution on the computer and to control the hardware interfaces on the computer as well. The Intel one provided has the user manual and the CPU itself. And the AMD one here has the user manual, the CPU itself, and a heatsink. Now, generally in the more overclockable CPUs, such as the Intel K series, a CPU cooler isn't supplied and you usually have to purchase an aftermarket cooler. This is also true with some of the higher end AMD Ryzen processors. Just check this before you make your final order. CPU ranges will have a specific socket or connection type, such as Intel's socket 1151 or AMD's socket AM4. These CPUs are also only compatible with their compatible manufactured chipsets on the motherboard. These are paired to the CPU and the socket type. These motherboard chipsets are generally released and phased out at the same time as the CPU to ensure support across various ranges. Now, like motherboards, there's varying different types of CPUs for the purpose required. Generally, the biggest change is their overall output speed. The several main influences are the processor frequency, which roughly translates to the overall speed, the number of cores, which was previously generally 4, now it's 6 to 8 in higher end gaming CPUs, the number of threads per core. Multiple threads allow for parallel execution on each CPU core. Lower end CPUs don't generally have this functionality. The ability to increase speed or overclock, and other items like the amount of cache available to each CPU core. So each of these influence how fast your CPU is going to be in your computer. But you need to consider when building the computer, what do you need the CPU for? Do you need a high-powered CPU for a gaming computer, or do you need a lower-powered one for perhaps an office PC? If you're after a lot more detail on how CPUs operate, you can actually download from our Easy PC Builder website the master course, which explains in much more detail the operation of CPUs. So when building and choosing a CPU, look at your budget and try to find a happy medium between the cost between your CPU, your RAM and your graphics card for best performance. Generally, for a gaming PC, your graphics card will cost twice your CPU cost. This combination will provide both a strong CPU and GPU for your purpose, as they both have differing complex roles. RAM of 4 to 8 gig in a gaming PC is usually acceptable. Some processors have integrated graphics on the CPU, so you don't always need a standalone graphics card. This is very useful for office computers which don't undertake overly complex graphics work, or if you're building a PC and waiting for your high-end graphics card. So in the gaming computer world, having the highest spec or the most expensive CPU in the computer doesn't always translate to the best graphics. Have a look at our section on video cards as to why this is so. So if you'd like to learn more, jump over to our website at easypcbuilder.com, where you can download our monthly updated build guides for gaming PCs of various levels, office PCs and media PCs, and you can also download our Easy PC Builder Master course. So now we're on to the RAM for the computer. So what does the RAM do in the computer? Essentially, it provides very fast working memory to the CPU to aid the data processing. The CPU has to call, store, read and write the working data somewhere at a similar pace to the CPU. The programs running tell the computer that they need particular data ahead of the CPU processing it, where this data is moved from the slower hard drive or solid state drive to the faster RAM for the CPU to work with, and old or finalized data is shifted back from the RAM to the hard drive and the solid state drive. This makes the computer data processing from the CPU much faster. So this is why you notice performance improvements in computers when you upgrade the size of the RAM, not necessarily the speed, because the CPU itself has much larger amounts of data to work with at any given time. Accessing the RAM optimizes the data flow to and from the CPU for processing, in place of accessing directly from the slower hard drives and solid state drives if the high-speed RAM space is not available. So RAM is called random access memory, and what this means is that data can either be written or read at random from any part of the memory. This is different to older storage methods that had to be stored sequentially. So RAM is known as volatile memory, and what that means is when you remove the power from the computer, such as turning it off or resetting it, you lose any of the data that was stored in the RAM. So what's in the box when you buy RAM? For this particular model, we have two 8 gig sticks, which are provided each in a stick. Now notice with RAM 2 that it's notched asymmetrically around the center of the RAM stick. This ensures that you can't plug the RAM stick in backwards to the motherboard, and this notch position changes with each DDR revision or the RAM voltage changes to make sure that you can't plug later model lower voltage RAM into existing motherboards, which can provide a higher voltage or generally be incompatible with the RAM itself. So the current DDR on the market is DDR4. This supersedes previous versions of DDR3 and DDR2. So you might see lots of RAM in kits, such as two 8 gig sticks in place of one 16 gig stick, and wonder, why do they have the two separate sticks? Essentially, it's to allow you to take advantage of a memory configuration known as dual channel memory, and it gives you a slight speed increase or processing increase as the RAM can be accessed in parallel to each of the sticks. We'll provide a link in the description which explains this in a bit more detail. So the main items to consider when buying RAM are the DDR type, the RAM frequency in megahertz, the RAM size in gigabytes, the voltage, which generally changes each DDR revision. The higher the frequency, generally the lower the voltage. So DDR4 is 1.2 volts and DDR3 is 1.5 volts. The CL or the CAS latency, which provides the latency or time between subsequent RAM cycles, and the form factor. So your desktop will be a DIMM or a dual inline memory module, and the laptop is known as a SODIMM or a small outline dual inline memory module. Make sure you don't purchase DDR4 laptop RAM for your desktop PC, as the small outline is much smaller and not compatible. Your CPU and your motherboard can only generally handle a maximum amount of RAM in your computer. This currently is around 64 gigabytes, but have a look at your CPU and your motherboard specifications to check this. You can download the motherboard and CPU manuals prior to purchase to help choose the right parts for you. And check your compatible RAM speeds with your motherboard also. Some motherboards might currently support up to DDR2666 MHz RAM, and where you purchase, say, DDR4 3000 MHz RAM, that will be an overclock. So you need to see if your motherboard supports the higher speed RAM or whether it will only support the lower speeds. Adding more RAM to a computer does allow your CPU to work with greater data amounts, but the speed increases that you get from adding more RAM to a computer is true only to a point. Most programs created will only request a certain amount of data at one time, but where you have multiple programs running, known as multitasking, each of these programs wish for their required memory to be loaded into RAM, where having larger RAM sizes will assist the computer operation, as there are multiple quantities of program memory required to be held in RAM to enable the fast data processing. So unless it's for very specialised tasks, we've found 8 gig is generally acceptable in a medium to high-end gaming computer. You can use 16 gigabytes if you have a very specific task or if you're looking to future-proof. Generally, if you've got the decision between, say, 8 or 16 gig of RAM and getting a better graphics card, we'd recommend getting the better graphics card every time. So let's talk storage technology, specifically the traditional hard drives and the more modern technology in solid-state drives. So what does the hard drives and solid-state drives on your computers do? Well, firstly, they're a non-volatile storage means. So basically, when the power to your computer is switched off or turned off, the data that's stored on this is retained. And essentially what these drives do is store your operating system, your programs, and any other files for your computer to access, use, and store to be used at a later time. So firstly, let's talk about the hard drives. Now, this is an older technology, but it still stores large amounts of data for quite cheap. Hard drives provide reasonable access times, but the speed of data writing and retrieval is hindered by the mechanical operation of the drive. The drive has spinning platters and a read-write head that has to position itself above the area of the platter where the data is stored. All of this mechanical movement takes time and hence delays the data read and write times. Modern day hard drives connect using the modern SATA 3.0 standard of 6 gigabits a second, which roughly translate to 600 megabytes a second, which provides easily for the maximum read and write rates of a modern hard drive, which is around 100 megabytes a second. An SSD is a much more modern storage technology and is also improving. SSDs are solid-state drives, meaning there are no internal mechanical moving components. This method of electronic storage and the memory used, NAND flash memory, and how this memory is accessed allows for much higher data read and write speeds. SSDs are generally 5 to 6 times faster than a traditional hard drive for read and write speeds. This SSD performance comes at a cost though. A traditional 1 terabyte hard drive costs around $80. But a 1 terabyte SSD would cost anywhere around $350, which is a premium of about 4 times. Now, the SSD technology has generally improved over the years, and this price should come down, but you do need to consider that price premium when you're choosing between either solid state or hard disk drives. So the existing data access protocol known as SATA 3 is starting to limit the speed that some of the fast SSDs can achieve. To get around this and provide higher speeds for solid-state drives, the M2 connector and the NVMe protocol is now used to transfer data much quicker to and from SSDs. The memory on the SSD is largely the same, but the communication protocol used is optimized for the use of SSDs rather than the traditional SATA method, giving yet again improved SSD and drive access speeds. An SSD compatible with NVMe comes at only a 10% price premium to a normal SSD, providing your motherboard offers the M2 connection type. A good quality NVMe SSD will provide a 5 times improvement over a traditional SSD read-write rate and a massive 20 to 25% improvement over existing hard drive speeds. Now, a question we commonly get asked is whether you need both a hard drive and a solid-state drive in your computer when you build a computer. Now, you don't need both of these if you're building a computer. You can use just a hard drive, but generally there comes improvements in speed if you choose to run either directly SSDs or more traditionally a combination of both. Our recommendation is that you use your larger hard drive, which is cheaper, to store your less frequently accessed files, which could be movies and larger files that are stored on the computer, and use your faster but smaller SSD to access your most commonly used files on the computer. So traditionally you'd install your operating system to your SSD, any games that you frequently use, and any other programs as well to make the best use of that space and available speed. This enables you to reach a happy medium essentially between either the large, slower storage and the smaller, faster storage that your system can provide. And lastly here, the DVD read-write drive and CD read-write drive. Now, generally these are becoming less and less common in computers. If you've decided that you want to install your operating system off of USB and download your games via the internet, generally there's not much of a requirement for this, so we see this as optional in some builds. So the part that most of you have been waiting for, the graphics processing unit. For any gamer, this is probably the hardest working part of their build and also probably the most expensive. The GPU purpose is to render graphics on your display, and it comes in two types, either integrated, such as on the CPU itself, which is a simple version ideal for office work and video watching, or a discrete, known as standalone card, primarily for high-end video games and visually demanding tasks for your PC. For this video, we'll be referring to discrete GPUs. A graphics card still undertakes computations like your CPU, but it's designed specifically for repetitive parallel render processing, having anywhere between 1,000 to 3,000 lower powered cores. Your CPU generally has 4 to 8 much more complex processing cores to compute more complex series executed instructions. Due to your graphics card parallel processing, it requires much larger amounts of working memory, such as 2, 4 or 8 GB of RAM on board. So when we purchase a graphics card, what's in the box? We'll open up the side here. Looking inside, we have, wow, actually a very nice unboxing. So in the top here, we have a package of components for the graphics card. We've got the driver CD, we've got a manual for the graphics card, we've got an 8-pin to 2 6-pin connectors, which I'll explain in detail in the build video, but essentially what this is doing is changing an 8-pin 150 watt power connector to two 70 watt power connectors for the video card. And we also have some cable management ties here. And under all of this as well, we have the graphics card itself. Now bear in mind the manufacturers might change what's included in the cases, but at minimum you could expect generally a power supply cable of this type. Some might not include it at all because it may be expected that your power supply does provide the compliant power inputs. But with anything like this, you'll get the graphics card at a minimum, the manual, and the driver CD as well. Generally, if you've already got an internet connection, the version or the driver version on this is generally already superseded. So I might recommend in any case jumping straight onto the manufacturer website and downloading the latest from there. So you don't always need a crazy top-of-the-line graphics card for gaming. Have a look and see what's best suited for your purpose. How many screens you're looking to run, the resolution that you're looking to run, and the refresh rate of the screens also. If you have lower end screens, a high-end graphics card might be completely wasted on that, so do your research beforehand. With any build, there's always a compromise when building to meet costs and computer purpose. But a key point for a gaming computer is not to buy the biggest and fastest CPU and skimp on the graphics card, as this will impact your gaming performance as your computer relies on your GPU to render the game images at high detail and frame rates. Generally, a mid to high range Intel i5, such as a 4 or 6 core, or an AMD 5 or 6 core processor is fine for a gaming PC. Then essentially spec the most reasonable graphics card for your budget. Our general rule for a gaming PC at whatever level is to spend 1.5 to 2 times the CPU price on your GPU for the best overall performance. With graphics cards especially, don't pay attention to the marketing. Look at the specifics of the GPU that you're looking to purchase. The GPU core type, such as a GTX 1060, 1070 or 1080, the GPU core frequency, the RAM type, the RAM interface width, such as 256, 384 bits, the RAM frequency, and the RAM size. Now, this list is ordered to what we believe most impacts performance to what least impacts performance. When you've chosen one or two cards that you deem best, either see reviews on websites, forums, and read their benchmarks online to compare the game performance to help you choose. So when choosing a graphics card, we recommend to choose a reasonably reputable manufacturer that has a good warranty, and also where you can, see if you can get a factory overclock version of the card, as generally this will run faster than the other versions of the same type, such as a GTX 1080 on the market, and the maker of the card will also warranty that even though they've overclocked the card from factory. Don't forget when installing the GPU also to connect the supplementary power connectors. So if you'd like to learn more, jump over to our website at easypcbuilder.com, where you can download our monthly updated build guides for gaming PCs of various levels, office PCs and media PCs, and you can also download our Easy PC Builder Master course. So now onto the computer power supply. The purpose of the computer power supply is to provide reliable controlled voltages to power each of the components inside your computer. The power supply primarily connects to your motherboard to power its components, but it also has direct connections to the CPU and the graphics card in most gaming computers. So let's have a look at what's in the box of our power supply. Inside, we've got warranty and user manuals. Now, as this is a modular power supply, here we've got some cable ties. But in here, we've actually got all of the power cables that connect into the PSU itself. If you bought a non-modular power supply, these cables would be hardwired into the power supply itself. We've got a power cord from the wall to the power supply, which will change depending on your country of origin. And we have the power supply itself. On the back of the power supply here, we've got our power in, we've got our power isolation switch, our fan, and on the front here we actually have our minimum power connectors hardwired into the power supply itself. So we've got our 24-pin motherboard connector and our 8-pin CPU power connector. As this is a modular power supply, the additional cables to power the graphics card and other external or internal SSDs and hard drives are optional, and you can connect them into the power supply as you wish. So the physical size of a power supply. Now, a significant number of power supplies are manufactured to a standard known as PS2, which for any normal office or gaming computer will generally be manufactured to this size. If you're going for a portable application or a high power application, the power supply might be larger or smaller to suit, but generally for most office and gaming computers, it will be of the PS2 size. So just a quick recommendation, if you need to, just check your power supply size when you purchase it and make sure it's compatible with the case that you've chosen. So the power supply wattage. We tend to find many people overrate their power supply unit, which is fine if you have additional expansion in mind. But where you're planning on not expanding, use an online calculator from a number of manufacturer websites to see what is best. And also so you can save money for other items like your RAM or GPU, or improve the quality of the power supply that you've purchased. Even for this computer being built, which has a very high-end graphics card, a 550 to 650 watt supply is acceptable with a 10% buffer for any further expansion. Most gaming PCs are fine with a 450 watt to 550 watt power supply if only using one discrete graphics card, but perhaps use 700 watts if you're using two discrete graphics cards in SLI or Crossfire configuration. So after you've decided on the wattage required of your power supply, you also need to decide on the quality and the efficiency of your power supply chosen. Generally, we recommend staying with reputable manufacturers, choosing an 80+ certification, and as well, just read the reviews online and check that the power supply that you're looking to buy has good, positive reviews over a long enough time frame. We recommend choosing a high quality power supply as it's the only thing standing between good, clean power for your computer and potential issues such as power offs and brownouts or just the computer power cycling at unknown times due to an unreliable or fluctuating power supply. So the power supply market has a voluntary certification program known as 80+, which in simple terms tests and certifies that power supplies have over 80% efficiency at certain loads, ensuring that the supplies are engineered well and they convert as much power into the unit to usable power in place of electrical losses and heat. Now, there are multiple levels of this certification, but any supply wearing this badge will at least be designed to be efficient and with good principles to meet the certification. It ensures your supply will be engineered with power efficiency in mind, will dissipate less heat, which will be more efficient, and will also provide less heat into your PC case as well when used. So from the power supply, there's three key power connectors that would be required for any gaming computer. First is your primary motherboard connector. This is a 24-pin connector that connects to your motherboard and provides power to most items connected to your motherboard. The second here is your CPU power connector. Now, this is an 8-pin power connector that provides power directly from the power supply itself to your CPU. And the third here for any high-end graphics card as well is either a 6 or 8-pin power connector, of which there is usually 2 off of any modern power supply. Graphics cards will either accept 6 or 8 pins. 6-pin is a 75 watt power to the graphics card and 8 pins is 150 watts. Generally, you'll either run the two of these in either 6 or 8-pin or a combination of both. We talk more about power supply mounting and the cables in our build video. So now onto the CPU coolers. Now, your CPU cooler under normal load tasks would generate heat, but this is especially true under high load tasks such as gaming. It's the role of the CPU cooler to keep your CPU temperature within a specified range to allow it to operate efficiently and reliably. So what's in the box for each of these CPU coolers purchased? So generally we have the heatsink itself, we have a series of bolts, we've got the mounting brackets for both in front of and behind the motherboard, some other additional adapter brackets, and in this as well we've also got some thermal paste to go between the cooler and the CPU itself. So what's in the box for this CPU cooler? We've got the CPU cooler itself, we've got the mounting brackets for both the back and the front of the motherboard, we've got the retaining brackets for the second CPU cooler fan, we've got some thermal paste, the user guides, the bolts, and some cables here to either split or slow down the fans to reduce noise. So the efficiency of a cooler is dependent on the amount of surface area the heatsink has to dissipate heat. The larger the surface area, generally the larger the cooler, and if you have a larger surface area with a large or several fans, you can control the high temperatures much more efficiently. Another bonus is as the cooler is more efficient, at lower loads you don't require high fan speeds to keep the heatsink surfaces cool, resulting in a cooler and quieter computer overall. A small CPU cooler with limited surface area can only increase the fan speed so much in order to control temperatures. And when the limit is reached, the CPU will begin to limit its processing and heat generated to ensure it doesn't damage itself. If you are keeping a CPU within manufacturer specifications, a stock cooler is fine, but where you tend to overclock it, increasing the speed and hence heat generated, you need to upgrade to ensure you don't hit this thermal limit. The installation of these larger coolers is usually more involved, with brackets required on both sides of the motherboard to support their weight. So another consideration is also water cooling, which is generally a more involved installation, but is also generally more efficient due to the cooling type used. Now, we find for general gaming PCs, the air cooling solution is fine, but water cooling in certain instances, especially with higher overclock computers, can be quite useful. We'll discuss water cooling in detail in a later video. So if you'd like to learn more, jump over to our website at easypcbuilder.com, where you can download our monthly updated build guides for gaming PCs of various levels, office PCs and media PCs, and you can also download our Easy PC Builder Master course. Thanks for watching.